Welcome to the r.avaflow tutorial video. This time we're going to look at the Linux version of r.avaflow. In this video I'm going to show you a brief overview of how to install the Linux version of r.avaflow, and I'm going to give you a short introduction on how to run your first simulation. Since there are many Linux distributions out there, I'm just going to show you how to install it for the recommended Ubuntu long-term release, which is mentioned on the landslidesmodel.org website. Also, since you are using Linux or plan to use Linux, I'm assuming that you know how to install software on your Linux machine. Therefore, I'm just gonna give you a brief overview on the necessary steps to install r.avaflow on Linux and focus more on the installation of r.avaflow into Graskis and how to run your first simulation. If you are having trouble with your installation, I recommend using an AI model such as Gemini, ChatGPT, Claude or any different kind of LLM. First things first, you need to go to the homepage of r.avaflow, landslidemodels.org, and download the source code for the Linux version of r.avaflow. The next step is to install all dependencies that are mentioned in the tab Get Ready for Using r.avaflow with Graskis. You need Python, R and Graskis. Also you need the Python package Pillow and some R packages. Dependencies and versions can always change, so make sure you're reading the r.avaflow documentation in detail and check if the information of this video is still relevant. As mentioned before, if you're using Linux, we assume that you know how to install software packages via the terminal. Since I'm on a fresh version of Ubuntu, I need to install all the dependencies. If you already know how to install this, skip this part of the video, but I'm going to still include it for people who aren't sure. If you're done with installing the dependencies, you need to extract the r.avaflow source code if you haven't done so already. The next thing you're going to need to run your first simulations is the Cascadia generic landscape. This includes ready-to-use data as well as different simulation scenarios. After downloading and extracting the folder, you can see the start script. We're going to use this later to start our simulations. If you want to create your own start script with your own data, take a look at the Windows tutorial video where I show this step in more detail. But before we can run our first simulations, we need to set up Graskis and install r.avaflow. Open your terminal and move to the location of your downloaded r.avaflow source code. After that, type in Gras to start Graskis. As mentioned in the r.avaflow documentation, tab 3, run your simulation with the start script, you need to create a new Graskis location with the generic X and Y coordinate system. For the map set, we can use the default permanent map set. After clicking Start Graskis session, the GUI will open. You can close it for now, we don't need it. Okay, we are now in an active Graskis session in our terminal and we can proceed with installing the r.avaflow extension for Gras. For this we can use the G extension command, which can be found in tab 1 of the r.avaflow documentation. Make sure you replace the default directory of the G extension command with the actual location of your r.avaflow source code. After the successful installation of the r.avaflow extension in Gras, you should be able to run the command r.avaflow-help with this outcome. Okay, the setup is complete and we can start with our first simulation. To run the simulation, we're going to need the start script in the Cascadia generic landscape folder, which I showed you earlier. Make sure you are in the location where the start script is located. For this example, I am in the Cascadia generic landscape folder. Just copy the name or type it into the terminal with the extension sh in front. After entering the command and hitting enter, the simulation should start. If you don't change anything in the start script, all models will run. This may take a while. If one model is done, you can go ahead and check the results. The other models will run in the background. If everything worked, you can start creating your own start scripts and create your own simulations. I hope this tutorial was useful and I wish you lots of fun with experimenting with your own data. If you have questions, leave a comment below.